This is a further math question on summation series, summer 23, variant 1-2. In this question, we have to find the sum of 1 over kr plus 1 times kr minus k plus 1. Before we find this sum, we have to convert the sum into its partial fraction. To convert it into its partial fraction, we have to let a over one of the factor kr minus k plus 1 plus b over the other factor kr plus 1, since both the factors in the denominator are linear of this rational function. So when we cross multiply the factors on the left side, we get a times kr plus 1 and b times kr minus k plus 1. If we plug in r equals to minus 1 over k into the equation, we can get the b value, which is minus 1 over k. Similarly, we can plug in any other r value to get the a value. So when we plug in r equals to 0, we get the a value 1 over k. So the fraction becomes, I'll replace a to be 1 over k and b minus 1 over k. Now to apply a method of differences, we have to plug in different r values in the partial fraction. So if I plug in r equals to 1 first, is going to be, when I simplify, I just have to plug in r equals to 1 here and here. That gives me 1 over k minus 1 over k times k plus 1. I can plug in second r value, which gives us, when we plug in r equals to 2, it gives us 1 over k times of k plus 1 minus 1 over k times of 2k plus 1. Let's just check for one more r value. Say it is 3. We have to write r values in the sequence, so it should be 1, 2, 3, and this gives us 1 over k times of, when we plug in r equals to 3, we get 2k plus 1 minus 1 over k times 3k plus 1. So these are the three initial values, and we have to plug in the last value as well, which is r equals to n. In the summation, we can see that r starts from 1 and goes till n. So we have to plug in r equals to n. When we plug in r equals to n, we get 1 over k times kn minus k plus 1 minus 1 over k times kn plus 1. You can plug in more r values to verify, but I think we get the pattern here. So we see that these terms are being cancelled. These are similar terms, so this will be cancelled with its next. Now this new will be cancelled with its next. Similarly, this will be cancelled with the previous term. So we will have, in the end, we'll have 1 over k here left, is 1 over k, and this term is left. So the two terms we have, 1 over k minus 1 over k times kn plus 1. So this is the sum required in the first part. The sum is 1 over k minus 1 over k times kn plus 1. Now in the second part, you have to deduce when r is from 1 to infinity. So we know that this sum is equals to 1 over k minus 1 over k kn plus 1. So if you plug in n equals to infinity, before we plug in, we have to check whether can we compute the value if n is infinity. So n is already in the denominator. If we plug in infinity for n, which is already in the denominator, that will become 1 over infinity, because infinity is added to something is still infinity, or when it is multiplied to some multiplied by some constant, that remains infinity. So what we have here is 1 over k minus 1 over k times infinity plus 1, which is basically 1 over k minus 1 over infinity, that gives you 1 over k. So if n goes to infinity, the sum is 1 over k. Sum approaches to the value of 1 over k. Now this is a repeated question generally in further math, where they change the r value. So now the sum is the same sum. We have to go back and check. This is the same sum, but this was from r equals to 1 to n. But now they are asking you to find the sum from r equals to n square. So when this sum is required from n to n square, we have to, let me write this first. So that's kr plus 1, kr minus k plus 1. So this should be equal to the sum from r equals to 1 till n square, and I have to plug in the formula. We have to pick the formula from the first part. This is the answer of the sum. Yeah, this sum we have to take. So I'm just writing in the sum form. So from r to n square minus from r1 to one of the previous terms. So here we have to start from n. So its previous term will be n minus 1. So from r equals to 1 to n minus 1. So now when we apply the sum formula, we know the sum formula is 1 over k minus 1 over k times n plus 1. So for the first sum, this we can plug in n equals to n square. It will be 1 over k minus 1 over k times k n square plus 1. This is the sum from r equals to 1 to n square minus, and I'm going to find the sum from r equals to 1 to n minus 1. So I have to plug in n equals to n minus 1 now. So the rest of the things remain same. So it's 1 over k minus 1 over k times bracket k times of n. N is n minus 1 here. And then we have a plus 1 inside the bracket. So if we simplify, we can see that after we open the bracket, these two terms will be cancelled, and we'll have this part positive, which is 1 over k times k n minus 1 plus 1. This will become positive. So I'm going to write it first. So this is 1 over k times k n minus 1 plus 1 and minus 1 over k times k n square plus 1. So we can take 1 over k common, and we can write our answer as 1 over k times n minus 1 plus 1 minus 1 over k n square plus 1. This is our answer.